We will now be starting a new unit looking at fluids over the next 2 weeks or so, which I think it can be one of the most fun units. We'll be doing some pretty cool examples and demos in class and a couple of cool, really interesting labs. So I think now that we've moved away from some of the kinematic stuff, we can get into the really cool physics, which is fluids, and then after that we have thermal energy and moving on from there. And then we get into electricity and magnetism, which is going to be even more fun. But here we go with our first little dip into fluids. A fluid is any material that can flow. This includes all gases and liquids. We'll look at a little bit more specific types of liquids and gases in a second. But we find density depends on the mass and the volume. So mass is M, and this is measured in kilograms. Volume is V. This is measured in meters cubed. Density is rho, kilograms per meters cubed. So you can have there. One thing to know, and as we move forward here, 1 kilogram of water has a volume of 1 liter. It's one of the constants that you should probably just commit to memory. Fluids can either be compressible or incompressible. Liquids are incompressible. This means that they have a set volume. You cannot take a cup of water and squeeze it into a smaller volume. No matter what, for a liquid, it's going to have the same volume. Now it can spread out and take up more area or more surface area, but it's still going to have the same volume. Gases, on the other hand, are compressible. This means that as you can push on them and apply a force and compress them down into a smaller area or smaller volume. When this happens, as we will look at later on when we get to thermodynamics, there's temperature changes that occur. Pressure is the force per area. It's when a fluid exerts a force over some surface area. We measure pressure in the Pascal. The atmospheric pressure at sea level is 1.013 times 10 to the 5th pascals. So 1 pascal is a very tiny amount. Below here are some other conversions that you may see for different types of ways to calculate pressures. Atmospheric pressure using for weather is sometimes done in millibars. So you have that there, so you can say like 1,013. That's sometimes another thing for meteorology. Pressure has no direction. It is a scalar quantity. The force applied is always perpendicular to the surface. In the case of a tire, for example, the force of the air on the inside, the pressurized air, is on the surface of the inside rim, the outside tire with a rubber tire, and the sidewall is always pointed perpendicularly. Here are 2 problems to go with the lecture. I grew up near Lake Sunapee, New Hampshire, and during the winter it freezes over. It's pretty awesome, actually. When it freezes over, you can drive out there, you can go skating. There's people that have that go like ice surfing with kind of like the wind surfers that do that with kites and all that. That's pretty awesome. But anyways, the lake freezes over in the winter, and the ice is an average of 0.6 meters thick. The lake has an area of about 17 kilometers squared. Pay attention to units. And I want you to tell me, what is the mass of all the ice? Use your textbook to find the density of ice. Question number 2. Mr. Wolf has a mass of 80 kilograms. A large nail has a diameter of roughly 2.5 times 10 to the negative third meters. What is the pressure exerted on Mr. Wolf if he, or myself, I'm talking, stands on the nail? And then I want you to explain to me, please, how a person can lay on a bed of nails and not be injured.